I had a walk-in customer recently come to the shop presenting with a large turbocharger, and this part had a flange with some holes in it that had become mangled and that all had to be welded up and remachined. Well, I don't ordinarily do automotive work like that, so I sent it to a friend of mine who does specialize in that sort of thing. But he kicked the job right back to me. And the reason why he kicked it back to me was basically for the same reason I sent it to him in the first place. The part was dirty and awkward, and it was just a large organic looking part with no flat surfaces on it. It had pipes and bosses sticking out of it, and just no obvious way as to how to hold this thing on a machine tool in order to do anything to it. So I thought about it for a bit, and I thought, okay, maybe I can help this guy out. Now, I wasn't able to capture this process on video because of time constraints, but I do have some photographs you'll see in a minute of the final result of this setup. But trust me, it was an hours-long ordeal of clamps and shims and jacks and straps in order to get this thing held on the machine just right, and also held down well enough such that I could machine on it. So the machining isn't really interesting. What is interesting and why I'm making this video is because it does showcase a use of the Cartesian display that made the setup a lot less painful. Okay, so here's what the part looks like, this turbocharger, and how it sat on the machine. You can see that it's just a really awkward part. Now, you can't see the gory details of how I got it to sit on there just right, but trust me, it was arduous. Here's the flange that needed the work, and here are the two holes that needed to be remachined. The flange needed to be nicely parallel with the table in case I needed to deck it off with a face mill, but also because the two holes needed to be perpendicular to the flange because new studs are going to be installed there. Okay, so I made a CAD drawing of the flange geometry. Not that I needed it to be able to machine the part, but I needed it to make this video to illustrate what I'm doing. So you'll recall that I had to move heaven and earth just to get this that flange parallel to the bed of the machine, right, in every dimension, right? Right, so I finally got it parallel to the table, all right, so that's all buttoned down. But in the process of doing that, I had to allow the part to rotate and skew itself in any way it wanted. I had to basically ignore the alignment of the part in this plane, right, in order to be able to get it flat and parallel with the table. So I just let it go where it wanted, okay? And it ended up at some funny angle like this, right, with respect to, say, the y-axis. And that's okay, because what I'm going to do is I'm going to create my own geometry that's going to accommodate whatever angle the part happens to be on at the moment. Now remember that on the part itself, it's these two holes that have been obliterated, and they're all going to be filled up with weld and just cleaned off and just erased from the part altogether. So we're going to be putting in fresh holes at these locations. Now, I was able to determine that this hole pattern is actually 60 by 120 millimeters. Now, these two holes are actually good, so we're going to need that information, because what we're going to do is we're going to use these two holes to build up some construction geometry to determine where these holes need to go, okay? Because, I mean, remember, the part is like this on the machine, okay? Okay, now, don't get nervous if this starts to sound a little complicated, because it's just going to be a long-winded way of explaining something that's going to take place in about a minute over on the machine. So we know that these 2 points are available to us, right? So what we're going to do is we're going to indicate this hole in, and we're going to establish a point there, and the point is going to be called P03. Then we're going to come down here, we're going to indicate this hole, all right, and we're going to establish that, and its name is going to be P04. The Cartesian display is going to make these names up on its own, right? It's going to name them for us. Now, we have 2 points in a plane. What can we do? We can connect those 2 points with a line, right? And now, we're already halfway there. We've got 2 points, we've got a line connecting them. All we have to do is erect the rest of this geometry in order to figure out where these points should be. So what we should do next is make a line that's parallel to this line, but 60 millimeters away, okay? So that's just what we're going to do. We're going to make a line parallel to that line, and it's going to be offset by 60 millimeters. And then what we're going to do is we're going to put a line through this point, and
perpendicular to this line, okay? So it's going to look like this, right? And this is going to be perpendicular, right angle. Then we're going to put the same thing. We're going to put a line through this point and perpendicular to this line, all right? Now you'll see when we go through this on the machine, it's going to name these entities for us. This is going to be called L05, line 5. This is going to be called line 6, L06. This is going to be called line 07 and line 08, all right? And remember, the system's going to name these for us, right? And then, finally, we have everything we need to figure out these points. We're simply going to tell it to compute the intersection of this line and this line. And when it does, it's going to call that P10, point 10. And then we're going to tell it to give us the intersection between line 6 and line 8, and it's going to compute that, and it's going to call it P09. Now we've got point 9 and point 10. These are the missing data that we need to machine these holes, okay?
Okay, so the first thing we need to do is get the machine located over this first hole. Indicate that hole in, and that's going to be called point 3, P03. All right, then move the machine down to this other hole location and indicate that hole in, and that's going to be called P04, point 4. Now we can connect those two dots and make a line through those 2 points, and then we can just go ahead and construct the rest of this geometry the way I showed on the board. And ultimately, we're going to get points 9 and 10, and those are going to be the locations of these holes that we need to machine. Okay, so now let's just go over to the Cartesian display and do this for real. Okay, here we go. Now, let's navigate up to that first hole. Okay. All right, let's say it was right there. All right. Now we go to Menu, Geometry, Points, Tool Position. Okay, so notice, and write these down as they appear. Point 03, that was that first point that I made on the drawing. So, by hitting that command, it latches the exact position that the machine's at that location where we indicated that hole, and it established a point there, and it gave it a name, P03. Okay, now, let's navigate down to that second hole, which is down here someplace, right? Okay, let's say it was right there. Now, okay, we indicate that hole in, get it just right, go back to the geometry menu, geometry, points, tool position. Bam, point 4, okay? So now we've got points 3 and 4. Now we need to construct a line between those two points, geometry, lines, point to point. So point 3, point 4, okay? So that was line 5, okay? Okay, now we want a line parallel to that, and it was 60 millimeters away. I'm actually not in metric mode now, so I'm going to use the decimal equivalent. So we're going to go to Lines, Parallel to line 5, okay? It's going to be the X large, XL. It's going to be the one that has the larger X component, right? So it's X large, and it's 2.362 inches, okay? And there it is, okay? So now we want line through a point and perpendicular to another line. So through point 4, perpendicular to line 5, okay? Voila, okay? One more. Line through a point, whoops, try that again, through point 3 this time, and perpendicular to line 5. Okay, there it is. Okay, now we want 2 points. So we want a point, and we're going to go to intersection of line and line. Int of line 8 and line 6. Okay, and that's this upper one here. All right, now we want, let's do that again, intersection of line 7
and line 6. Okay, there it is. That's point 9 and point 10. Okay, so now we go back out to our regular screen here, and we see all of our construction geometry. And you see we have, that's point 9 and point 10. And now we can just use the radar to navigate to those points and machine those hole locations just like normal. I'm not going to demonstrate that because I've done it in a bunch of other videos. And by the way, you could also put a hole there. You could draw a circle there representing the hole. But a point is just as good. You can navigate to that point with the radar and get precisely on that location and drill it and mill it and tap it, or whatever else you need to do to it, okay?
All right, one more thing and then we'll be finished. Imagine, if you will, that a repair job like this was something that came up more or less routinely in your shop. In that case, having a CAD model that represents the geometry that is necessary to carry out the machining process might come in really handy. Like earlier I showed that CAD model of the flange and the 4 holes and all that. I didn't need that to do this job. I just needed it for illustration purposes to make this video. But if it was a job or something like it that came up routinely in your shop, having that CAD model would be really handy. For instance, in our case, remember I had to indicate in those 2 holes, right? And from there I built up all the other geometry. But in this case, if I had that CAD model, all I would have to do is indicate in 1 hole and set that as the origin, and then indicate the other hole, and that allowed me to connect the dots and make that line. So with that line, I now know what angle that flange is oriented at. And so with those 2 little nuggets of information and the CAD model, I don't have to construct any geometry at all. All I have to do is bring up the model, set the origin, and rotate that geometry to the angle that I determine from that line, and you're off to the races. You don't have to construct anything. Points 9 and 10 that I use to machine, they'll be already embodied in the model. So you just go right to work on the part without having to construct anything. I'll demonstrate that right now.
Okay, so to do the same job except using a CAD model, we can proceed almost the same way as we did before. First, you need to navigate the indicator up to where that first hole was. Remember, it was in the upper left corner of that flange. Indicate that hole in, and now what we're going to do is we're going to use the draw feature. See, draw. Okay, and it says locate first point, hit OK. So I hit OK. Good. Now, we would move the indicator down to that other hole. Remember, it was down here to the lower right a little bit. Okay, let's say it was right there. We indicate the hole in, and we hit OK. Okay, now it drew a line between those 2 points. Okay, and notice that the line is red. That means it's on radar. And any entity that's on radar, you can just hit the OK button, and it will tell you everything about that entity. In this case, it's a line. And so it's telling me that the line is at a reference angle of 75.664 degrees. Okay, so I'm going to write that down, 75.664. Okay, now, forget all this. Now bring in the model. It's called Turbo 1, right? Now, I would indicate that. I would go back to this hole here and indicate it back in, indicate that hole in exactly. And I would set the origin of the Cartesian display to 0, 0. System set XY 0. Okay, bam. Now XY 0 is that upper left hole, right? Now all I have to do is calculate the angle that I need to rotate this thing, because remember, this thing's going to be cocked off on some angle. So I'm going to take 90 minus 75.664 degrees, and that's 14.336. So I go to Menu, Rotate Part, and let's say, for the sake of argument, I happen to know that the part, it needs to rotate this way, okay? That's counterclockwise. And it's actually 14.336 degrees. So rotate part, enter angle, minus 14.336, okay? Right there, enter. And there it is. So now the geometry of our part is rotated at that angle. The origin is right here. Now we can just navigate to these holes, just like you've seen me do a million other times in other videos, and machine these holes, okay? We don't have to construct anything. And so the next time this job comes along, you just do the same thing. You figure out what the angle is that it needs to rotate to using the draw feature, or any number of different features of this system will give you that angle. And then bring up the part model, rotate the geometry, and you're off to the races. Thanks for watching.